In this example, we're asked to find the domain of the following function and then write our answer using set builder notation. So recall when you're asked to find the domain of a function, you're simply being asked, what are all the numbers you are allowed to plug into the function? So recall the restrictions are you can plug any number in, but you cannot plug in a number that would make the bottom undefined. So in order to find out what numbers you can't plug in, take the bottom and set it equal to 0, then solve for x, and that number will be the number that you're not allowed to plug in. So let's go ahead and do that, taking the bottom and set it equal to 0. The first thing we need to do to solve for x is to add 10 to each side, then divide by 5, and x equals 2. So that means I can plug any number into this function, but the one number I cannot plug in is a 2, because 2 would make it undefined. So the way we would write that in interval notation form would be x is such that x cannot be 2. And what that means, the same thing as saying it can be any real number, but not 2. So let me show you proof here. Let's go ahead and plug in a 2 in x's place and see what happens. So when we remove the x from the original equation and replace it with 2, we have on the bottom 5 times 2, which is 10, and 10 take away 10 equals 0. So as you can see, that is a true statement that 2 will make the bottom undefined. And that is the reason why the domain includes all numbers except 2. And there you have it, finding the domain of a rational function.